Alright, here's a review of sine, cosine, and tangent, and inverse sine, inverse cosine, and inverse tangent, all going to be using the same triangle because for us to use sine, cosine, or tangent, or inverse sine, inverse cosine, inverse tangent, it just needs to be a right triangle, and then it's dependent on the side lengths that we have and the side lengths we're looking for, or the side lengths we have and the angle we're looking for, and let's see what I mean there. And so what I'm going to start with is this. I'm going to call this right here a 25-degree angle, okay? Then that would be my reference angle. That's the angle that I'm going to be working with to solve for missing sides of this triangle, okay? And whenever I'm solving for a missing side of a right triangle and I know one of the angles, I'm going to be using sine, cosine, and tangent. Sine, cosine, tangent is to find missing sides of the triangles, okay? So if this is my angle here, the 25, that means this side is my opposite because it is across from my reference angle. This side is my adjacent because it is between my 90 and my reference angle. And this side is my hypotenuse because it is across from my 90-degree angle. Okay? Now let's see a couple of examples. Okay? Let's say my opposite side is x, so it's a side that we're looking for, and my hypotenuse is 7. Okay, this is where Sohcahtoa comes into play. Sohcahtoa. That's going to help me decide which do I use, sine, cosine, or tangent in a problem like this. Well, I see that I have an opposite side and I have a hypotenuse. There's nothing there for adjacent. So I have O, I have H. That is a sine problem. And so the way I set it up is doing the sine of my angle, which is 25. I put that over 1, and I set it equal to the opposite divided by the hypotenuse because O comes before H in so. So opposite divided by hypotenuse, that's x, divided by 7, and I cross multiply and solve here for my answer. Let's change up the problem a little bit. Say that this isn't my x, and say I change the x and the 7. Okay? Maybe my x is right here. So my hypotenuse is x, my adjacent is 4. Well, again, my angle, my reference angle is 25. This time I have adjacent hypotenuse, and I'm trying to solve for x. Well, adjacent hypotenuse, that is a cosine problem because Sohcahtoa, AH, adjacent hypotenuse. So I'm going to set it up to try to solve for x here using cosine. Okay, so I would do the cosine of my reference angle, which is the cosine of 25 because that's still my reference angle, over 1, set it equal to the adjacent divided by the hypotenuse because adjacent A comes before H in Ka. So adjacent divided by hypotenuse, so then 4 divided by x, and I would cross multiply and solve. Let's change the problem again so we can see it as a tangent problem. Okay, so we're getting rid of that being the x, then we're going to get rid of this being the 4. And let's say that I want my opposite side again to be x and my adjacent here to be 6. Well, now my problem from my reference angle is still 25. I have the opposite side, that's x, and adjacent side, that's 6, nothing for the hypotenuse. So opposite, adjacent tells me it is a tangent problem. Opposite, adjacent goes with TOA. Okay, so I can set this up as a tangent problem now. And what I do is I do the tangent of my reference angle, which is 25, put that over 1, and I set it equal to the opposite divided by the adjacent because O comes before A. So this is x over 6. And I can cross multiply and solve this here. Okay? Another way that this works, and so we're going to clear everything here, and I'm going to keep Sohcahtoa because we're going to keep looking at this. But let's say that I have this angle here. So I'm just changing the angle. So I used to have this one down here, which was 25. Let's have this one here, and let's call it 65. So now my reference angle is up top, and it's my 65. So let's label my sides again. Now this is my opposite, because now this is across from my reference angle. This is now my adjacent. This side is now my adjacent because it's between my reference angle and my 90. and this is my hypotenuse because it's across from my 90-degree angle here. Okay? So I could start creating problems again, and I could give you x is the opposite side and 7 is the hypotenuse, and now you have a sine problem because it's opposite hypotenuse. And if I do the sine, it's the sine of my reference angle. So this time it would be the sine of 65. And I would set equal to opposite divided by hypotenuse because O comes before H. And so that would be x divided by 7. I can put sine over 1 and I could cross multiply and solve here. Okay? So really, the heart of sine, cosine, and tangent is evaluating which sides of a right triangle do I have. In this case, you can see I have opposite adjacent, I have nothing, or sorry, I have opposite hypotenuse, I have nothing for adjacent. So opposite hypotenuse tells me sine, and I always set it up, if it's a regular sine, cosine, tangent problem, I always do the sine, cosine, tangent of my reference angle, I put it over 1, and I set it equal to, in the case of sine, opposite over hypotenuse. In the case of cosine, I set the cosine of the reference angle over 1 equal to adjacent divided by hypotenuse. If it's a tangent problem, I do the tangent of my reference angle, set it equal to the opposite divided by the adjacent. Okay? So let's look at what it means to use the inverse then. Okay? Inverse, we can still kind of think of Sohcahtoa here, but the problems look a little bit different because in regular sine, regular cosine, regular tangent, we need to look for a missing side. We're solving for some side length x. When we use inverse, so sine inverse, cosine inverse, or tangent inverse, we're looking for a missing angle. So let's say that this is my missing angle down here. Let's call it a theta. Okay, that becomes my reference angle again, so I can again label my sides. If that's my reference angle, this is opposite, this is adjacent, this is hypotenuse. Okay? So if I want to find, if I want to use or create a problem that uses inverse sine, inverse cosine, inverse tangent, I need 2 side lengths. And so let's call the opposite side 6. Let's call the hypotenuse 8. Okay? Well, again, I have, evaluating my Sohcahtoa, I have opposite hypotenuse. I'm looking for an angle. I'm looking for the missing angle. So this is going to be a sine inverse. Okay? So anytime you're looking for an angle, it's an inverse. Because it's opposite hypotenuse are the sides that are given, it's a sine inverse. And the way I set this up then would be to do the sine inverse of the opposite divided by the hypotenuse, so 6 divided by 8. Whatever that equals is going to be my angle, is my missing angle. And this can be done on your calculator. Okay? And let's take a look at a Google calculator here to see how we can type that in. Oops, I don't want pictures of calculators, I want just the calculator. Sorry for the delay here. Okay, make sure again your calculator is always in degrees, we're working in degrees. And then you click this inverse button, or maybe on your calculator it's the second button, and you get the chance to do sine, cosine, tangent, inverse. Well, I just did the sine inverse. You gotta click again, sine inverse of 6 divided by 8, which would give me a 48.59 degree angle. Okay, so whatever my answer is my angle there. Let's see another example using one of the inverses. So I'm going to get rid of the 6 and the 8. And let's have the opposite side be 7, the adjacent side be 2. This is still the angle that I'm working with, and I'm looking for a missing angle again, so I know it's going to be an inverse problem. This time I want opposite adjacent, and so that's going to be the tangent inverse, because TOA, opposite adjacent. And so I do the tangent inverse of my opposite divided by my adjacent, which is 7 divided by 2. And whatever that equals is going to be my missing angle again. Okay? So you can see the difference when I do a regular sine problem. A regular sine problem is the sine of the angle equal to opposite divided by the hypotenuse. If I do a sine inverse problem, it is the sine inverse of the opposite divided by the hypotenuse, and it equals my angle. You can see how they're inverses of one another. Okay? Same thing goes for cosine and tangent. If I do the cosine, regular cosine is the cosine of the reference angle set equal to the adjacent over the hypotenuse. Cosine inverse is going to be the cosine inverse of the adjacent divided by the hypotenuse. It's going to equal my angle. Okay? And every time we do inverses, we can just put it into a calculator. Every time we do regular trigonometry, sine, cosine, and tangent, we just set it up as a cross multiplication and solve. And again, we do use our calculator, but that's because the cosine of our angle is always a decimal. Okay, I'm going to stop the video here. If you have more questions, if you want more clarification, just reach out and ask.